In this work, we present CAMION, a Cascade Multi-Input Multi-Output network for skeleton extraction. Skeletonization is a morphological processing function that decreases the foreground regions in an image to obtain the simple skeleton lines. An accurate medial axis transformation can remove redundant information while maintaining critical topological and geometric properties of the object, which facilitates the extraction of object features in subsequent tasks, for example, human action recognition, segmentation, and so on. Although the shape of the object directly contains the geometric information of a real object, it contains limited semantic information. This leads to weak supervision signals. On the other hand, we find that some skeletal lines extracted using deep learning methods are discontinuous. For the first problem, we believe that introducing multitask learning can help the network to obtain more general feature representation with limited input signal. Specifically, we introduced two auxiliary tasks, feature point detection and contour extraction. The motivation of using feature points as training signal is that we observe the skeleton in some non-trunk regions are frequently missed by the model, and the supervision of contours constrains the range of skeleton and can avoid false positive pixels to some extent. We use the sheet-to-mossy corner detector and find contours function in open CVPR in feature points and contours GT. For the second problem, we use Cascade network with multi-input. In CAMION, all tasks share the backbone network and generate their own masks through several lightweight heads. With multitask learning, we get the skeleton, feature points, and contour of the shape image through forward propagation. In the first stage, the skeleton is relatively coarse and discontinuous. Then, we concatenate the coarse skeleton with the original shape image and feed them into the network again. In this stage, we obtain a more refined skeleton than the previous one. After several refinements recursively, the final skeleton result is generated. For the skeleton input of the first stage, we use the Jansun-Sinning algorithm. It also allows our network to converge quickly in the early epochs. At a micro level, we embed the concurrent spatial and channel squeeze and excitation module, spatial pyramid pooling module, and an ensemble attention module to our network. The overall loss is weighted by the skeleton extraction, feature point detection, and contour extraction losses. The weighting factor for the auxiliary tasks is set to 0.1. The losses for all three tasks are weighted by focal loss and dice loss. For data augmentations or possible flips and rotations, multiple 90 are used. In addition, we randomly remove some lines from the input skeletons in order to better enable the Cascade network to learn the potential task of connecting discontinuous skeletons. In the specific implementation, we use a coarse cutout only for the skeletons before feeding into the network. Table 1 shows the ablation experiments of several modules of our basic network. Table 2 presents the results after using the multitask learning and cascade manner, where cascade indicates that only one additional cascade process was performed. The feature point detection task brings a surprising improvement for skeleton extraction, with the score increasing from 0.8051 to 0.8162. The improvement from the contour extraction task, although slight, further demonstrates that the multitask learning is feasible in skeleton extraction. After using the cascade manner, CAMION achieves a performance 0.8289 on the official testing set. This achieves state-of-the-art result compared to the results of previous pixel skeleton competitions without using extra tricks. CAMION is potential and generalizable. For multitask learning in CAMION, more relevant tasks can be introduced, such as the classification of shapes. The categories are indicated in the image names, and the cascade manner in CAMION can be generalized to future models with better performance. Thank you for watching.